All right. So we're briefly going to go over one from each section just to give you guys an idea and a guide as far as when you're working on it tonight. Okay, then I'll let you guys get back to it. But as of right now, we're going to do this. Now, on the first one, something you should notice, and this is a case with all these, is that a lot of these are a lot harder than anything we've done so far. That's designed on purpose. Again, as a study guide, I want this to be harder than the test. The test will be a lot easier. Most of these will not be set up like this. Everything will be on one side to start. I might have one like this, not five. Okay, just to give you guys a breather. Now, first thing, however, let's figure out how we're going to do that, though. I'd recommend getting everything to one side, obviously. You can't factor it like this. Got to get everything to one side. So what I'm going to do is I'm going to add 5x to both sides first. Okay, so we're going to add 5 to both sides. That gives me x squared plus 5x equals 14. All right, so next up, we're going to subtract 14 from both sides. So we get x squared plus 5x minus 14 equals 0. Okay? Now that is something we can factor. 0, we don't really care about the right side of the equation at this point. We're done with it. It's gone. We can factor that, right? I need two terms that multiply together to give me negative 14. And I saw this in last block. A student did this. I thought it was pretty cool. They drew an x, and then they put the term that they want to add on the bottom. Not a bad strategy because at least it organized a bit better. So now I need two terms that multiply together to give me 14, but add together to give me 5. And obviously it's going to be positive 7 and negative 2. Okay? I like that setup a lot more than the T-chart personally because it saves space mainly and compacts it down. Okay? So from there, that means that my answer is going to be x minus 2 and x plus 7. So there's your answer for the first one. And 1 through 4 is going to be like that. Okay? So there's a freebie. You're going to get 3 freebies on this. Okay? The next one, okay, which is number 5. Okay. So moving on. Down to number 5, as I said. Okay, number 5. We've got 3uv minus 2u plus 12v squared minus 10v. So first thing is, you need to recognize this is all grouping. That's what these are. This one right here is grouping, okay? I don't know if all of these are. I think some of them might be special cases, but for all intents and purposes, this one's a grouping one, okay? So firstly, though, we can factor something out of all this. We can factor out... Actually, no, we can't factor out. Okay, we just got a group. Parentheses here, parentheses here. Out of here, I can pull a 5u. That leaves me with 6v minus 5. Plus, I can pull a 2v out of this one, because 12 and 10 are both divisible by 2, right? Again, it leaves me with 6v minus 5. There are your twins. You're going to take them out. That leaves you with 6v minus 5. Whatever's left over, bring over here. You have 5u plus 2v. And there's your answer. Okay, so moving on from number 5. What you're going to do, let's go ahead and jump and do one of the special cases back here. Let's do this one here. This is a special case. Okay? This one, I would recommend rewriting as 81n squared minus 0n minus 36. Nothing wrong with doing this. Adding the placeholder back in helps you identify, one, that you can factor as a trinomial. And then when you don't have to that, you have to say to yourself, oh, well, take the square of both, and you have to make sure you have the right signs, and remove some of the guesswork. Add the placeholder. Perfectly fine. Okay? So, factor out a 9. Everything in here is divisible by 9. Yes, 0 is divisible by 9. Why? Because 0 divided by 9 is 0. Perfectly legal math move. Okay? So I have 9n squared minus 0n minus 4. I need, here's my x over here. I guess I'm doing this in red ink this time for the numbers. I need two terms that multiply together to negative 4, add together to give me 0. Obviously, it's negative 2 and 2. Okay? From there, we just need to know we got to split this guy to 3n and 3n. Bring down my leading coefficient. Right of parentheses, we have 3n. Close, open, 3n. Bring our numbers from here over. So then we have negative 2 and positive 2. And there's my answer. Okay? All right, for 13, we're going to do the rainbow method here. And then on number 14, I'm going to do something called slide and divide. We haven't seen that method yet, but I've been encouraged to show it, so at least that way we have it in a video, and you guys can compare them side by side to see the pros and cons. Okay? So for 13, again, let's do the rainbow. So we're going to take the leading term, multiply it by the last term. Okay? That leaves me with, in my x over here, let's see, 3 times 56, I believe, is 168, so negative 168. And I need two terms that add together to give me negative 13. Remember, in the graphing calculator, okay, break it out. You turn the brightness up 1 second so that way you guys can see this. Okay, oh, too bright. There we go. All right, go to calculator here, there, whichever you have. Negative 168 divided by, here's your x key. Click it. Okay, then you do second graph. And there is your table. Okay? Now we're going to find two terms that add together to give me negative 13. Let's see what we got here. I'm thinking 21 and 8. Sounds good. So we'll do 8 and negative 21. Okay? Turning down the brightness again so that we can see. All right. So from there, this guy splits to negative 21x and 8x. We have discovered also last block, the order of these two terms do not matter. If you want to do 8x first, then negative 21x, fine. You're still going to get the same thing. It has been corrected. Okay? Personally, I like to rig it, basically, in my favor, as any con artist would. Rig it in your favor. That way you don't have to necessarily worry about the order, though. If you know that 3 and 21 are divisible, put 21 first. You put 8, you're going to factor an x out, you're going to get the same thing, but at least it takes some of the guesswork out. It's going to look prettier, it's going to make more sense. Okay? So, from there, I then have 3x squared minus 21x plus 8x minus 56. Ooh, I'm encroaching. Hold on a minute. I need to move that over. And I just ran out of whiteout. No! Come on. Just ran out. Sugar. All right, well, bring these down. Bring this down. So 3x squared minus 21x plus 8x. And bring them over here. Minus 56. Group them up. So we factor 3x out of this. We get x minus 7. Factor positive 8 out of this. We get x minus 7. There are my twins. Okay. Bring these guys down. So you get x minus 7 times 3x plus 8. All right, and there's number 13 by using the rainbow method. Number 14. Okay. So first thing I would do here is I would factor out a 2. So you have 2x squared plus x minus 20. Thank you. 10. Thank you. And I don't have any more whiteout. 10. So that is a 1 right there. I apologize. Make it blocky. There we go. That is a 10. All right. Now, how slide and divide works is the following. Step 1. You slide. You take your leading term, like the rainbow method, and multiply it by the last term. Okay? That gives you, over here in our x, negative 20. And we want to know how to get positive 1, meaning the coefficient of x here. Step 2, we factor. Okay? So we basically ignore our leading term. We just put x here and an x here. Factor of negative 20. Also, two numbers that get multiply together give me 20. Negative 20. Adding to give me positive 1 would be 5 and negative 4. Very easy numbers to work with. We put them in here. Okay? Now, and then number 3. This is where things get weird. You have to divide. By what? Well, you divide by your leading coefficient that you multiplied your previous c term with. This is where I don't like this. I'll do it in pink. The reason why is because if it doesn't factor, you have to take it and move it to the front. And on top of that, if this had, let's say, had been 10 over 2, no, bad one. Let's say it had been 8 over 4. You have to reduce it, then you get to move it. It's an extra step that doesn't really get a lot of attention because it's not baked into the arithmetic. Okay? So it's a good strategy to use if you're struggling with Rainbow, but it does have its one glaring weakness, just like basically FOIL does, where it can only work with certain numbers, certain setups of polynomials, or you basically say expanded FOIL and push that aside. It's just distribution. But there are always going to be backdraws to different methods of solving factors, guys. You just got to find which one you're willing to basically work with and accept that you're going to have to be conscious about. You can't just fall asleep and do it. Okay? So again, just to finish this up, you move it over. That leaves you with then 2x plus 5 and x minus 2, which means that part is bottoms up. You're taking the bottoms and putting them upstairs in front of the x. And that's the other method, and that's called slide and divide. This is Rainbow. Okay, we're going to do one more, and then I'll let you guys do your own devices. On the second page, on number 17, we're going to do, just to clear up some confusion involving the wording. Okay, so 17. I'm just going to refocus here. There we go. So 17 is basically asking you. So when it says solve each equation by factoring, we already know how to factor it. Some of these guys are actually pre-factored. What it really is asking is the solve portion. When you say that, you need to think of find the zeros, or AKA the roots. Okay? So, the first one is designed in such a way to where you don't need to worry about factoring. All you got to do is set it equal to 0 and find what the value you would plug in to get 0 would be. In other words, you take this guy over here and this guy over here, split the binomials up from the factored form, and set them both equal to 0. For every single binomial in a problem, that is one potential 0. And think about this for a second, all right? If I were to factor this back out, I would get an n squared, right? Remember at the beginning of the unit, I told you the number of the highest degree in a polynomial tells you the number of zeros possible. Yes. So if you have two binomials from a quadratic from a polynomial that was squared as its highest degree, you should have 2 equal to 0 right now. It's a built-in check mechanism. If you don't, something's wrong. All right? Now, from there, let's go and solve for n. Add 1 to both sides. Okay? I get 5n equals 1. Divide by 5. I get n is equal to 1/5. Other one, subtract 1 from both sides. 4n equals negative 1. Divide 4 from both sides. You get n equals negative 1/4. Okay? Now, you're asking yourself, but why are there still 2 answers? Here's why. If I plug either of these in, I'm still going to get 0. Here's why. All right, let's try this one first. I'll do this one in pink and the other one in green. So if I plug in this into my polynomial up here, or my binomials, I have 5 times 1/5 minus 1 times 4 times 1/5 plus 1. Okay? All right. So, and this is equal to 0. Okay? I'll highlight that in green. I should have wrote that in pink. Okay? This obviously goes to 1. 1 minus 1. And this becomes 4/5 plus 1. I really don't care what happens here. Because 1 minus 1 is 0. And 0 times anything is 0. So 0 equals 0. It checks out. If I were to plug the other one in, this guy right here, and did another one, I'll do it over here. So if I had 5 times negative 1/4 minus 1, I'm going to encroach on number 18, but I'm not doing that one anyway, so it's okay. Okay. Times 4n, times negative 1/4 plus 1 equal to 0. I would get negative 5/4 minus 1. Again, I really don't care what happens here because I get negative 1 plus 1 equals 0. That whole thing goes to 0. So I have negative 5/4 minus 1 times 0. This whole thing goes to 0, so 0 equals 0. And that's why there are 2 answers. That's why we have 2 intercepts. And hopefully that makes sense. You're having an aha moment, because when we talked about graphing in the previous videos, again, that's not on the test, so don't worry about it. But you should